Hello, it's Dave Giles here for the next lesson of Cambridge International IGCSE Physics and Unit P1, Forces, Motion and Energy. And today we are looking at momentum. And today I want you to recall and use the momentum equation in units, describe and apply the principle of conservation of momentum, and describe impulse and use it to calculate force. So momentum is the product of mass and velocity. And the bigger the momentum of an object, the harder it is to stop the object. So momentum is mass times velocity, where momentum is measured in kilograms meters per second, mass is measured in kg, and velocity is measured in meters per second. So a quick example question here. John Lomu, former rugby player, has a mass of 105 kilograms and runs at a velocity of 10 meters per second. Calculate his momentum. So his momentum is mass times velocity 105 times 10, which is 1,050 kilogram meters per second. Okay. So here are some more momentum questions. Pause it, and I'll put the answer on in a few seconds. And the answers are as follows. Okay. So now, that's the first lesson objective complete. Recall and use the momentum equation and its units. So now, we're moving on to the second learning objective, which is describe and apply the principle of conservation of momentum. And I'm just going to play a little video of me skateboarding here. Very short video. So as you can see, that's me jumping off a skateboard, and I move forward, and you'll notice the skateboard all moves, but it moves in the opposite direction. It moves backwards. So let's actually have a look at some maths. First of all, we'll start with the conservation of momentum law, which states that total momentum before equals total momentum after. Okay, 1 second. So I have a mass of 120 kg. I've lost a little bit of weight since then, but I'm going to use the same figures just to keep it simple. Now, a skateboard's not going to have a mass of 5 kilograms, but I'm using this just to keep the mass very, very simple. Mr. Dave steps off at 0.5 meters per second. What velocity does a skateboard move at? Sorry about that. So total momentum before, well, I was stationary at the start. So the total momentum before is going to be 0. So that means, according to this law here, momentum before equals momentum after, that the total momentum after must also be 0 kilogram meters per second. However, we can break it down to different parts. My momentum after, well, we'll just use these numbers here, is 120 times my mass of 120 times my velocity of a half a meter per second, which is 60 kilogram meters per second. So therefore, the skateboarder, what I need to add to 60 to get 0 is negative 60. So the skateboard has a momentum of minus 60 kilogram meters per second. Rho equals mv. Minus 60 equals 5v. So v is minus 60 over 5, which is minus 12 meters per second. Now, the negative just means that it's going in the opposite direction to me. So I treated my velocity of 0.5 meters per second as positive. So the skateboard is negative because it's going in the opposite direction. Okay. So moving on. Here is quite a challenging question. Bob has a mass of 75 kg. Whilst out for a morning jog, traveling at 6 meters per second, he bumps into John, who has a mass of 100 kilograms, who is walking at 1 meters per second in the same direction as Bob. Bob instinctively grabs John. At what velocity did they hurtle together forward at? So in this example here, they're both going in the same direction. Bob is behind, but he's running a lot faster than John, and he hits John, and they basically grabs onto him, and they fall forward together. Okay, so give me 1 second. Okay, so if you've already done that, then great. If not, I will talk you through how to solve this question. So the first step is total momentum before equals total momentum after. M1v1 equals M2v2. So M Bob V Bob equals M John V John, which equals M2v2. Now again, I'll let you pause. If you hadn't solved it and this helps you, I'll let you pause it and try it. So mass of Bob is 75 times 6. Mass of times the velocity of momentum of Bob is 75 times momentum of Bob is his mass of 75 kilograms times his velocity of 6 meters per second. The momentum of John is 100, which is his mass, times his velocity of 1. That equals 175 v2. Now, it's 175 because Bob has grabbed onto John, and they're together now. So they're classed as one mass. So I rearrange this, and I get V2 is 75 times 6 plus 100 times 1 over 175. Stick my numbers in the calculator, and I get 3.14 meters per second. Okay. I will let you pause on this, and I will put the answers on in a few moments. Okay. Put the answer onto the first two sections, and then I will talk you through the third section. So, here it's stone miles per hour because the mass is stones and the unit of speed is of velocity is miles per hour. Clearly answer. The units of momentum are just the units of mass and velocity combined. Now, this one here is quite a challenging question. So you've got a diagram showing the car and the lorry about to collide. When they collide, the two vehicles become tightly locked together. So they're classed as one body, effectively. Calculate the speed of the vehicles immediately after the collision. Show you're working. There is no need to change to standard units. Give your answers in kilometers per hour. So the lorry here is 20 kilometers an hour, 9.5 tons. Speed 40 kilometers per hour and 0.5 tons. Like it says in the question, we don't need to convert. As long as we keep our units the same throughout, it's fine. So the momentum of the lorry first is 9.5 times 20, which is 190. Again, I am not putting the units on just yet. And then we'll do the momentum of the car here. So 0.5. Now, the negative in the mark theme, it has in brackets because you didn't necessarily need to have it, but I think you probably should. So 0.5 times negative 40, because it's going the opposite direction, which gives you minus 20. So the total momentum before is 190 minus 20, which is 170. So total mass after is now 10 tons because it's joined together, 9.5 add a half, which is 10. So 10 V2 equals 170. V2 is 170 over 10, which is 17 kilometers per hour. And will the two vehicles move in the original direction of the lorry or the original direction of the car? Well, the lorry had a lot more momentum and is a lot more massive, so it's going to be the lorry. And that's the second learning objective complete. The third one is describe impulse and use it to calculate force. Impulse is the change in momentum of an object due to a resultant force. Impulse is also equal to the average force applied to the object multiplied by the time that the force is applied. So, from previous lessons, we know that A is V minus U over T. So, acceleration is change in velocity over time. From today's lesson, we know momentum is mass times velocity. And from previous lessons, we know that F equals ma. So by substituting, instead of A, writing V minus U over T, we've got F equals m, V minus U over T. F equals mv minus mu over T. So this is change in momentum. And we've said here, impulse is the change in momentum. So we can say here that, so I've took the T across to the other side. So this is impulse, F force times time, which is mass times velocity. So mass times final velocity minus mass times initial velocity. And the units are going to be, well, it's newtons times seconds, so it's going to be Newton seconds. So let's take a look at an example question with this. A ball is a mass of 2 kilograms. The ball approaches the wall at a speed of 3 meters per second and rebounds at a speed of 1 meters per second. What's the impulse on the wall? I'll give you a few seconds to have a go at it. Okay, if you want to pause that, then I'll put the full question on because this was a paper 2 question. So it had multiple choice. So that might make the answer a little bit easier. So let's go through it. Impulse is change in momentum. So mv minus mu. So I've actually done it the other way around in this working here, but it doesn't really matter. So 2 times 3, even though I've used the I've done it the wrong way around, but it just means I'll get a negative answer instead of a positive. I made a positive instead of a negative. So 2 times 3 minus. Now, what you've got to take into account here is the fact that it's now going in the opposite direction. So because it's going in the opposite direction now, you have to put a negative with the speed. So it's -2 times -1, which gives you 8, and the units are Newton seconds. So we've already defined impulse. And look at the equation for impulse. What determines how much damage is done in a collision and how it can be reduced? So the size of the force controls how much damage there is. Momentum is conserved in a collision, so impulse is constant. So to reduce the force, the time of which the collision takes place should be increased. So you want to extend the time of the collision, which is why we have safety features in cars which try and increase the time of the collision. There's one you can see in this picture, which is the crumple zone. We'll talk about that in a second. In a car crash, force and therefore damage is reduced by increasing the amount of time over which a collision occurs. Seatbelt stretch, which increases the collision time, which reduces the force. Airbags do something similar. They reduce the time it takes your head to come to rest. Crumple zones, which is the bit at the front of the car which collapses if you have an accident, rather than just suddenly rather than just suddenly break, it crumples slowly or relatively slowly, and increase the time of which the collision takes place due to the time it takes them to crumple, reducing the force exerted. Okay, have a go at these questions around momentum, impulse, and force. The last one being a full past paper IGCSE question. And I'll put the answer on in a few seconds. Okay, answers to the first section. And answers to the full exam question. Okay, and that's it for today. The next lesson is on Hooke's Law, which I will be uploading fairly soon. Thank you very much, everyone, and I'll see you later.